All right, lesson 10.4 is all about the Pythagorean theorem and kind of what the Pythagorean theorem is, how it applies to our problems, and things that we can do working around the Pythagorean theorem. So, some key terms. Now, Pythagorean theorem only applies to right triangles, so it's any triangle that has a 90-degree angle. And remember, we draw a 90-degree right angle with this little box. So, as long as your triangle is 90 degrees, or has a 90-degree angle, that side that is across from the 90-degree angle is called the hypotenuse. So the hypotenuse is the side opposite of the right angle in a right triangle. It's always going to be the longest side as well. Because it's across from the biggest angle, it's going to make the biggest side. Now the legs are the two sides of the right angle that form the right, or of a right triangle that form the right angle. Now it doesn't really matter which one is which. We can call this one A and this one B, or this one A and this one B. Really doesn't matter, but they are just considered legs, is what they are called. You can call it the short leg and the long leg, A and B, whatever it is, as long as C is for sure the hypotenuse, A and B can be either one. It doesn't matter. Converse. Now the converse of a statement is just mixing up the hypothesis and the conclusion of an if-then statement. So if I said, if it is a dog, then it has 4 legs. Well, that normally should be true. Most, all dogs should have 4 legs. Now, the converse of that statement would say, if it has 4 legs, then it is a dog. Now, that's not necessarily always true. There are cats with 4 legs. There are deer with 4 legs. There are pigs with 4 legs. So the converse isn't always true, but we're going to see that sometimes both a regular statement and its converse can be true. Pythagorean triple. Pythagorean triple are whole numbers that satisfy the Pythagorean theorem. So when we go over the Pythagorean theorem, there are a few numbers that will always work for A, B, and C that make a right triangle that are whole numbers. So they're not decimal values, they're not square root values, they're whole numbers that will make a right triangle every time. So the key concept of this lesson is called the Pythagorean theorem. Now it says if a triangle is a right triangle, so if this is going to be a right triangle, then if you square the hypotenuse, it's equal to the sum of the square of the legs. Now, how else can we say that with symbols? A squared plus B squared equals C squared. Or you can kind of mix it around and say C squared equals A squared plus B squared. That is the Pythagorean theorem. As long as this is a right triangle, then A squared plus B squared equals C squared. So, I'm going to write that down at the top of all of our examples. A squared plus B squared equals C squared. We're going to go over some examples of what this looks like. So example 1, we have a right triangle here. You can see where the right angle is. We know this length here is 15 miles. This length here is 12 miles, and we're not sure how big this one is. So we can find this one out by using Pythagorean theorem, the A squared plus B squared equals C squared. Since this is the longest leg, or the longest length side, it's across from the right angle, that's going to be our C value, the hypotenuse. Now, x and 12, those can be A or B. It really doesn't matter. So just pick one, plug it in there. So, plugging in these values into the Pythagorean theorem gives us x squared plus 12 squared equals 15 squared. At this point, all we've done is just plug in these values into the Pythagorean theorem. Now we start to simplify and solve it out. 12 squared is 144, 15 squared is 225. Now, to get rid of these, kind of move things around, we just subtract 144 on both sides, minus 144. Okay, that's going to cancel this term out. So right now, our equation says x squared equals 81. Now, how do we get x alone? What do we have to do to both sides? Well, we would get the square root of both sides. Now remember, square and square root will cancel each other out. Doesn't matter if the square is on the outside or the inside. Right now, this squared is on the inside of the square root. Doesn't matter if it's on the inside or the outside, they will cancel each other out. So this side is now just x. This is the square root of 81, which remember can be either positive 9 or it can be negative 9, because negative 9 times negative 9 is positive 81. But if we think about it, does it make sense to say that this is negative 9 miles long? No, it does not. So we kind of ignore the possibility of a negative, and we just say positive 9 is our only answer. So x has to be 9. It has to be 9 miles long. And this would be our final answer. So let's look at another example. We've got another right triangle. We know the two legs, 15.2 yards and 7.3 yards. We don't know the hypotenuse, the longest length there. That is our x value. So when we plug everything into the Pythagorean theorem, it's now 15.2 squared plus 7.3 squared equals x squared. So like before, we just simplify everything. 15.2 squared becomes 231.04. 7.3 squared is 53.29, and x squared stays the same. Combine these two terms, and we get 284.33 equals x squared. To solve this out, we square root both sides. When we do that, squared and square root will cancel out. Same thing, this could technically be a positive or a negative value, but it wouldn't make sense to say this is a negative amount of yards. So we get rid of the negative possibility. It can't be there. It can only be a positive number. So we take the positive square root of 284.33. You could just plug that into your calculator. And it did say round it to the nearest tenth. So we round it off and say x is approximately, or x is around 16.9 yards. And that would be our final answer. All right, let's look at another example. In this case, it says leave your answer in simplified radical form, no decimals. So all we're going to change for this one is instead of plugging it into our calculator, we'll just simplify our answer at the end. Same process though. We have a hypotenuse of 15, we have one leg of the square root of 37, and one missing leg. Plugging it into the Pythagorean theorem, we get x squared plus square root of 37 squared. This was a, this was b. A squared, b squared equals 15 squared, or c squared. Now, like before, we can remember that squaring a square root, they just cancel each other out. So this is now x squared plus 37 equals 15 squared is 225. Now we need to subtract 37 from both sides, minus 37. These are going to cancel out, so now we just have x squared equals 188. Now how do we get x alone at this point? We'd have to take the square root of both sides, and like before, we only want the positive answer. Squaring the square root cancels out, so we would say that x is the square root of 188. Now we'll leave it in a radical form, but we need to try to simplify it. So as we try to break down 188, we've done that in lessons before. 188 would be 4. We could break it down into square root of 4 times square root of 47. Square root of 4 is 2, so we call it 2 square roots of 47. And this would be our final answer then. We don't plug it into the calculator, we don't try to solve it out, we leave it in its simplified radical form. All right, example 4. A squared plus b squared equals c squared one more time. So we just plug in everything we know. 10 squared plus 8 squared equals x squared. Simplify those pieces. 10 squared is 100, 8 squared is 64. Add those together. 164 equals x squared. We'd have to take the square root of both sides. So I'll show you what that looks like. Square root here, square root here. Squared and square root cancel out. So now it's x equals the square root of 164. Again, you'd normally think could be positive or negative, but we don't want a negative amount. This should not be a negative amount of yards. Then we have to break it down. Square root of 164 breaks into, I'm going to go this way, square root of 4 times the square root of 41. And we know that the square root of 4 is actually 2. So it's 2 square roots of 41. And that would be our final answer. Now we're going to go on to looking at the converse of the Pythagorean theorem. We know for sure that if a triangle is a right triangle, then a squared plus b squared equals c squared. Well, it's also true that it goes the other way. If a triangle has side lengths a, b, and c, and we know that c squared equals a squared plus b squared, then it must be a right triangle. So, looking at some of our examples, we are going to use these side lengths to say whether or not these are right triangles. If these match up and a squared plus b squared does equal c squared, then it will be a right triangle. If not, then it's not a right triangle. So, for example 5, if our triangle looks something like this, and we know that this is 3 yards, this is 3 yards, this is 5 yards. Now you can do this in real life. You can take a board that is 3 yards long if you want, so that's kind of a long board. So one that's 3 yards, one that's 3 yards, and one that's 5 yards, and put them end to end like this, and see if it does actually make a right triangle. Now, what we're doing is just taking the numbers. Instead of actually putting the boards together, we're just going to see with just the numbers if it would actually make a right triangle. So we plug those in. The longest side here, 5 yards, has to be our c value. So we're saying, does 3 squared plus 3 squared equal 5 squared? Does it? We're not sure. That's why there's a question mark there. Simplifying those down, 9, 3 squared is 9, 3 squared is 9, 5 squared is 25. So does 9 plus 9 equal 25? Well, 9 plus 9 is 18. Does 18 equal 25? Well, no, obviously it does not. So we would have to say, in this case, unfortunately, no, it is not a right triangle. We know that because a squared plus b squared does not equal c squared. So since it does not, it is not a right triangle. For example 6, instead of drawing out the picture, they just told us, here are the following lengths. So if your board was the square root of 17 inches long, one board was 13 inches long, and one board was the square root of 186 inches long. If you put those end to end, would they make a right triangle? Well, let's check. We'd have to do the square root of 17 squared plus 13 squared. Does that actually equal the square root of 186 squared? Now it's kind of nice that these lengths were square roots, because when we square it, they just cancel out. That and that. And then 13 squared is 169. So it now says 17 plus 169. Does that equal 186? Well, let's combine those over here. 186. Does that equal 186? Get a nice green check mark. Yes, it does. These do actually check out. So if we were to lay 3 boards end to end, of these lengths, yes, they would form a right triangle. And we know that because a squared plus b squared does equal c squared. So it has to be a right triangle. Moving a little bit past that then, let's say that we figured it all out and c squared did not equal a squared plus b squared. Well then, what does it make? What kind of triangle is made? Well, if our hypotenuse, this piece, is less than a squared plus b squared. Now think about what that would look like. If we have 2 legs here and here, and this hypotenuse is actually less than these 2 added up. So think about what that would look like. It would mean that this length shrunk. So maybe it only went to here, which means this side length actually goes to here. So we can kind of erase what these look like. Leave that triangle. What kind of triangle did we make then? Well, that would actually be acute. All of these angles are going to be smaller than right angles. So if c squared is less than a squared plus b squared, it makes an acute triangle. Thinking about it in the other way, if we were to extend this hypotenuse, make it go further, and then connect these other, well now, what have we made? That looks like an obtuse triangle. Okay, it's now there's one big obtuse angle here. So it would be an obtuse triangle if our c squared was bigger than a squared plus b squared. So let's check it out with a couple examples here. Using these side lengths, we need to determine if it's an acute triangle, an obtuse triangle, or a right triangle. Remember, it'd be right if c squared equaled a squared plus b squared, obtuse if c squared was bigger than the other two, acute if c squared was smaller than the other two. So here we have our a, our b, and our c value. Plug them in for Pythagorean theorem. Square root of 5 squared plus 2 square roots of 2 squared. Does that equal square root of 13 squared? Now, I put all of this one in parentheses because it's this whole length that is the side, like all of this together. So when we do 2 square roots of 2 squared, what we mean is 2 square roots of 2 times another 2 square roots of 2. Now when we match our whole number parts, 2 times 2 makes 4, times we match our square root parts, square root of 2 times the square root of 2 makes the square root of 4. We know the square root of 4 is 2, so 4 times 2 actually equals 8. So this thing squared will become 8. For these pieces, that cancels out with that. That cancels out with that. So right now, our equation says 5, right here, plus 8. We figured out that this would have to be 8. 2 times 2 is 4. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2, so 4 times 2 is 8, right here. Now, does that actually equal square root of 13 squared, which is 13? Let's check it out. 5 plus 8 is 13. Does 13 equal 13? Yes, it does. Since it does equal 13, we would have to say this one is a right triangle. Because a squared plus b squared equals c squared, it is a right triangle. So, example 8. We're going to use these lengths. 14 meters, square root of 95 meters, and the square root of 26 meters. Does this make an acute, obtuse, or a right triangle? Well, let's check it out. We'll just plug all those pieces into our Pythagorean theorem. Again, squared and square root cancel out, squared and square root cancel out. 14 squared is actually going to come out to 196. So our question is, does 95 plus 26 equal 196? Well, 95 plus 26 is 121. 121, how does it compare to 196? It's a lot smaller. So we would say our c value squared over here is going to be bigger than a plus b. Each of them squared. C squared is bigger than a squared plus b squared. So according to our rules, when c squared is bigger than a squared plus b squared, it makes an obtuse triangle. So we would say then this would actually be an obtuse triangle. It does not make a right angle, so this figure is not drawn to scale. This is not what it would look like. It would actually look something a little more like this. This would have to go a little further that way, and this would have to look like that. So it would make an obtuse triangle if they were exactly these lengths long. All right, last example. Example number 9 says, find the area of the triangle, round intermediate values to the nearest tenth, use the rounded value to calculate the next value, round the final answer to the nearest tenth. Now the question is, find the area of the triangle. So kind of to review from previous years, the area of a triangle is 1/2 times its base times its height. Now we can use our Pythagorean theorem, a squared plus b squared equals c squared, to figure all those out. Right now, we don't know how long this base is. We only know this part is 11. We also don't know how long this height is. But we can see that this triangle has been cut into 2 smaller right triangles. Here's a right angle. So since it's on a straight line, this has to be a right angle as well. So we can use Pythagorean theorem with 16 and 11 to find this missing piece, the height. So as we plug it in, we'd get x squared plus 11 squared equals 16 squared. I'm going to call this height x. And I guess then I would call this length over here y. There we go. So Simplifying those pieces out, x squared plus 121 equals 256 minus 121 on both sides, which means these will cancel out, and we now have x squared equals 135, which means x is the square root of 135. We just took the square root of both sides. So plugging that into our calculator, rounding to the nearest tenth, x is going to be about 11.6. So this thing right here is about 11.6 units high. Now we need to solve for y, this piece here. So we have a right triangle, hypotenuse of 21. This leg is 11.6. We need to find this missing piece. So we'd say y squared plus 11.6 squared equals 21 squared. Simplifying all that out, we get y squared plus 134.56 equals 441. Now we don't need to go this far out. We're only looking for tenths. So actually, I guess we would round that up to 134.6. So y squared plus 134.6 equals 441. Now, to get rid of that on both sides, we'd minus 134.6. And on this side, 134.6. That means those are going to cancel out. And we are left with y squared equals 306.44, which again actually should just be 306.4. We are rounding to the nearest tenth each time. So y squared equals 306.4 means we have to take the square root on both sides. This is going to cancel with this. And it now says y equals the square root of 306.44, which again we can take out that part, round it to the nearest tenth. Solve that on your calculator, plug it in, we get y is going to be about 17.5, approximately. So now we know this length and this length. We need to find the entire base of this triangle and the height. We already found the height. So we would say the base is 11 plus 17.5, so it's going to be 28.5. Here was 11, here was 17.5. Add it all together for this entire base, and it's 28.5. The height we solved for as x was 11.6. So, using our formula for area of a triangle, it's 1/2 times base times height. When we plug in the pieces we know, 1/2 times the base, which is 28.5, times the height, which is 11.6. Plug that all into your calculator, and in the end we'll get the area of this triangle is 165.3 units squared. We're not sure if this is inches or yards or what, but whatever units it is, it's squared units. And that would be your final answer to solve for the area of that triangle. You'd have to use Pythagorean theorem twice to find some pieces and then plug it into the formula. And that'll be it for our fourth video.